What is the Nusselt number in convection heat transfer? Imagine you're trying to warm up a room. The heat moves from the heater to the air and then around the space. But how do we measure how effectively that heat is spreading? That's where the Nusselt number comes in. It's a way to see how much better convection is at transferring heat compared to just conduction. In fluids, heat moves in two main ways: conduction and convection. Conduction is like heat traveling through a solid object, moving from molecule to molecule. Convection, on the other hand, involves the bulk movement of fluid, carrying heat along with it. Near a hot wall, conduction dominates because the fluid is almost still. But farther away, convection takes over because the fluid starts to flow and mix. The Nusselt number is a simple ratio. It compares the heat transfer happening through convection to what would happen if only conduction was involved. Mathematically, it's written as the convective heat transfer coefficient times a characteristic length, divided by the thermal conductivity of the fluid. The convective heat transfer coefficient tells us how effectively heat moves from the surface into the fluid. The characteristic length could be the diameter of a pipe or the length of a flat plate. The thermal conductivity measures how well the fluid conducts heat on its own. If the Nusselt number is 1, it means convection isn't helping at all, and heat is only moving through conduction. When the Nusselt number is greater than 1, convection is making heat transfer more efficient. For example, in smooth, slow-moving, or laminar flows, the Nusselt number might be between 1 and 10. But in turbulent flows, where the fluid moves chaotically and mixes a lot, the Nusselt number can reach hundreds or even thousands. That shows convection is doing a much better job at transferring heat. Engineers use the Nusselt number to predict how well heat will transfer in systems like cooling electronic devices, heating water in a tank, or airflow over buildings. It's often linked with other numbers like the Reynolds number, which tells us about the flow type, and the Prandtl number, which relates to the fluid's properties. These relationships help create formulas to estimate heat transfer in different situations without doing complex experiments every time. So, in simple terms, the Nusselt number is a handy way to see how much convection boosts heat transfer compared to conduction alone. It helps us understand and design systems where heat needs to move efficiently through fluids. Whether it's cooling a computer or heating a house, knowing the Nusselt number makes it easier to predict how well heat will flow.